Here we've got a child pulling the sled up a hill. The hill is inclined at 10 degrees. So it's kind of level ground here. This hill is inclined at 10 degrees above horizontal. Child's pulling the sled up the hill. They're pulling it so that it accelerates at 2 meters per second up the hill. I'm going to make an assumption here. It doesn't actually say this in the question, but I'll assume that the motion is in the direction that the child's pulling and the acceleration is going. I think that kind of makes sense, or at least that's a typical situation. It does mention that there's a force of friction opposing him. We don't know what the value of friction is, but we do know mu. So to help us out with this, we're going to draw a free body diagram. Almost always, it's always good to have a diagram. Good to have a free body diagram as well. On a free body diagram, the force should come from a dot in the center of the object. So here's my dot. Here's my applied force. Gravity, remember, is straight down. That's not quite straight. There we go. Gravity is straight down. Gravity, remember, is perpendicular to this to level ground. Not perpendicular to the surface, but perpendicular to this level ground down here. We're going to have a normal force. Normal force is perpendicular to the surface that we're on. So if I continued this line back, it would be perpendicular. There'd be 90 degrees there. So there's my normal force. Assuming that the motion is up the hill, friction opposes motion. Also happens to oppose applied force in this case. And I'm going to say FFK, just to remind us, this is kinetic friction. We're talking about mu K here. The object's at rest, it's sliding. So the object's in motion, it's sliding. When I look at this thing then, not all forces are on nice grid lines, which means I'm going to have to break some forces up into components. Before I do that, I want to decide on what my coordinate system is going to look like. Where's my X and Y direction? To help me decide that, I'm going to find out what direction is acceleration. We're told this acceleration is up the hill. Okay, so when I choose my coordinate system, I'm going to draw it over here. I want my coordinate system, I want to pick a coordinate system so that acceleration lies on one axis of the coordinate system. It doesn't have to be X, it could have been Y. But I'm going to choose so that it lies on, in this case, the x-axis. That's going to help out because, like a lot of questions, this is kind of like a theme that we're going to have in grade 12. We're going to have to look what's going on in the x direction, what's going on in the y direction, and I don't know, let's kind of start to separate this here. We're going to have to look and say, I'm going to use Newton's second law, F equals ma, in the x direction. I'm going to have to use Newton's second law, F equals ma, in the y direction as well. Okay, so just like we did with projectile motion or acceleration in 2D, any of those things, this is going to come up over and over in grade 12 physics. We're going to look x and y direction and see what's happening. By noting where the acceleration is and by choosing a coordinate system so that the acceleration lies only on the x-axis, this acceleration is ax. That also means then that ay is 0. Okay, so you don't have to do this, but it's my kind of tip to you. Figure out where your acceleration is, choose a coordinate system so that one of your accelerations, ax or ay, doesn't matter which, but typically it's going to be ay, so that is 0. That's going to make our life a little bit easier. Once I have a coordinate system, I need to break up all those forces so that they lie, their components lie on that coordinate system. Okay, so Fn, Fa, Ff are all already on this coordinate system, so here's an added bonus. My acceleration lies on the coordinate system. Most of my forces do. I only need to break up Fg into Fgy. Okay, so here's my y-axis, here's my y component. And x component, remember, parallel to this line, parallel to that line, so x component is kind of coming down this way. Here's Fgx. This 10 degrees, so this 10 degrees is right here. That 10 degrees is right here. Okay, and it may take a little bit of playing around to see that, but if this angle here is 10 degrees, let's put it over here again. If that angle is 10 degrees, Fg is perpendicular to the surface of the Earth over here, so there's 90 degrees, here's 90 degrees. That must make this 80 degrees. I don't know if you can read that, but that's his 80 degrees. Because Fgy has to be perpendicular to the surface that we're on, right? The normal force is perpendicular to the surface. Fgy now is perpendicular to the surface. This whole angle adds up to 90 degrees, so 90 take away that 80 is 10. That angle will always be the angle between Fgy and Fg. Okay, so if you can just remember that, that angle is that angle. If I continued and made a big triangle here, there's 90 degrees. This would be 80 degrees. Down here is also 80 degrees. I'm not going to use that. I'm just going to use that 10 degrees right there. If this is 10 degrees, then I know what FG is. FG is mass times 9.8. Okay, so we'll do that work over here, but I can use cosine of 10 degrees to find the y component and sine to find the x component. Okay, this question asks us to find the normal force. Normal force, obviously in the y direction. We're going to look over here in the y direction. I've chosen up as positive. So this sum of F, or F net, means add together the normal force and FGY. That means add together all the forces in the y direction. In this case, Fn is positive, it's up, minus FGY, or you could say plus negative FGY, same thing, equals 0. FGY I'm going to bring to the other side. What we're seeing here is Fn is not equal to Fg. Fn is equal to FGY. Okay, so it's a little different than maybe what we're used to. In grade 11 physics, you might not have seen that. In grade 12, this will start to get common. We know what FGY is. FGY is Fg times the cosine. It's adjacent to that angle, so cosine 10 degrees. Fg is mg, cosine 10 degrees. You don't need to show me all these steps, but I just want to show you where this thing comes from. Okay, so this FGY is going to be mg cosine of 10 degrees. We know what mass is. It is 3. G, 9.8. Cosine, 10 degrees. Fn is 28.9533. Okay, we'll round for sig digs here. It's approximately 29 newtons. And we could say, I don't know, you could say up or in the positive y direction, something like that. Typically Fn is just a magnitude, so you could just say 29 newtons, but forces are vectors, so if you want to be really good communication, state that direction in there. So that's part A. I should have mentioned that, I guess. That whole thing is part A. This is the answer to part A. For part B, we're looking for the applied force. Now the applied force is in the x direction. We're going to have to look over here. When we say sum of forces in the x direction, it means add together all the forces in the x direction, including any components. Okay, so there's 3 of them. I've chosen kind of up the hill to be my positive direction, so I'm going to say Fa minus force of friction minus Fgx equals mass times acceleration. The acceleration is in the direction of my positive x stuff, so I can just say this mass is 3, this acceleration is 2. I know the right-hand side, we could say equals 6. We'll get there in a sec, but I need to fill in some of these things. So I do not know what Fa is. I don't know friction, but I know that friction is mu times the normal force. Okay, so part of the reason we had to go through all this, I'd say typically in a question like this, I wouldn't ask you part A, I would just ask you part B, but you're gonna have to go through all this to find out what the normal force is. That's gonna go in right over here. Fgx, kind of like we said over here, I'll write it in pieces, but Fgx is gonna be Fg sine, because that's opposite to that 10 degrees, so Fg sine 10 degrees. Again, like we did over here, Fg is mg sine 10 degrees. Again, you can jump right to this step if you want. That's 6. Fa minus mu Fn. Let's start subbing in some of these numbers as well. So Fa minus our mu value, 0.32. Our Fn, I'm going to use this unrounded Fn, so 28.9533. Mass is 3 kilograms. G, 9.8. Sine, 10 degrees equals 6. We got a bit of math to do in here. I'm going to assume that you can do this math. You can find this number. It's around 9.265. This number, 5.105. We're going to take those to the other side. Remember, they're both negative, so we're going to bring them to the other side. They become positive. Fa is 20.37, and we'll round for sig digs. So Fa approximately 20 newtons And again, we should put a direction on the applied force. I'll say positive X direction. You could say up the hill, parallel to the hill, I don't know, something like that that indicates this direction, or in the direction shown in the free body diagram, something like that. And there it is. It's a lot of work for one of these questions, and we'll get used to this, but we're gonna have to look in the Y direction, find normal force, look in the X direction, find out whatever it is they're asking for, in this case, the applied force. Good stuff.